Hello children, welcome back, and today's topic is angle bisector theorem. Sarah constructed a triangular house, and if she wants two windows exactly at the same distance from the middle of the door, how to find? Yes, if she knows angle bisector theorem, then it is easy to find the equal distance from the middle of the door. So let us start. Let's have an arbitrary triangle ABC. From an angle B, draw an angle bisector. So children, you may have a question here, why we are taking an angle bisector from an angle B? That's a nice question. We could have done it with any of these three angles. So we can take any angle, angle A or angle B or angle C. So every triangle has three angle bisector, and this angle bisector never goes outside the triangle, which means it is inside the triangle. So what is the definition of an angle bisector? The line segment from the vertex of an angle that bisects the angle is called angle bisector. And this angle bisector divides two smaller triangles, which means ABD and CBD out of that larger one. Children, are you able to observe angle ABD and CBD are equal to each other? Yes, they are congruent. Children, now let us go to the statement of angle bisector. So the internal bisector of an angle of a triangle divides the opposite sides internally in the ratio of the corresponding sides containing the angle. So what does the angle bisector theorem tells that? The ratio of the other two sides of triangle, which means AB by AD is equal to BC by CD are going to be the same. How we are going to prove? We are going to prove this by using similar triangles, but unfortunate here is these two triangles, which means ABD and CBD, are not necessarily similar. We don't know about the angle A and angle C. So how we are going to prove? In order to prove AB by AD is equal to BC by CD, we have to construct another triangle that may be similar to any one of this triangle. So this proof can be done through Geogebra. Children, let us see the geometrical proof of angle bisector theorem by using Geogebra. For this, I am going to open Geogebra Classic here. In that, take a triangle of A, B and C. From B, draw an angle bisector. And this point is D. So the angle bisector divides into two smaller triangles. Let us check the angle. So it is 40.08 degree. Let us keep the value alone. So it is also 40.08 degree. Children, now what we have to prove? We want to prove that the ratio of AB by AD is equal to BC by CD. This is what we have to prove. Now for this we want to construct a triangle which may be similar to any one of this. So I am going to take a parallel line from C which is parallel to AB, and this point is E. Children, the angle of ABD is 40.8 degree. Now let us check the angle of DEC. What about this angle? Let us check that. This line BD is a transversal and AB and EC are parallel lines. So that AB is equal to EC. Now let us check the angle of CED. So it is also 40.71 degree. Okay. So the angle of ABD and the angle of DEC are equal. So Now let us check about this alternate opposite angles. So it is 89.27 degree. Let us keep the value alone here. So it is also 89.27 degree. Children, now are you able to observe this triangle ABD and triangle of DEC are similar? Why? Because these two angles in this triangle, these two angles are same. And what about this triangle? These two angles are same. If two angles of any two triangle are same, then it is called a similar. So this triangle ABD is similar to triangle of DEC. These two triangles are similar. Now let us write the ratio as AB by AD is equal to and EC by CD. And what about EC? EC is nothing but BC because these two are same, right? So AB by AD is equal to BC by CD. This we have proved in the GeoGebra.